So we've gone over how to use futures with async and await and raced against two web pages in the last video. But what if we wanted to take it a step further like this? We can run these tasks, which truly give our program something to do when we're blocking with async. In this example, we're creating this task that prints 1 to 10, and then we're not awaiting this task, although it kicks off the future right here. And in the meantime, we're going to go straight to here, and we're going to go ahead and print our number from our secondary task. And then during this await here, the runtime's gonna look for something to do. And we have this task running right here, so we're able to run things concurrently, truly. So we'll go ahead and do a cargo run just to see this work. So as you can see, we're running these concurrently, and we are awaiting down here because otherwise our block would exit and it would just automatically terminate this future here. So we're awaiting for this first task to wrap up with this await right here. We can also write this out in a different way. Instead of spawning a task, we can declare two futures here, and we declare futures with the async keyword followed by a block. And we created a future here. Note that these aren't running yet, they're just futures waiting to be kicked off. And we kick them off with join. This does the exact same thing, except it's deterministic. It switches between the two futures evenly instead of letting the runtime scheduler decide which future to run. So in the business logic side of things, it's pretty much the same, but under the hood, we're always going to see it interleave with the first and second task. See, like right here, with our first example, we got a non-deterministic output, and we printed two outputs from the first task and then switched to the second task. Here, we're guaranteed to interleave between the two. So I'll go ahead and cargo run real quick. As you can see, we're always going to be switching between the first and second task, and then we're going to finish up our first task as it has a longer asynchronous runtime. We also have this concept of channels like in multi-threaded programming with the TRPL crate. So we have a transmit and a receive side. So here we're declaring a couple values, and then this is going to execute linearly. So we're going to wait until we send everything in the transmit side of the channel. Then the buffer is going to be full in the channel, and then we're going to go ahead and loop through all the values, except this is going to deadlock at the very end. So it's going to wait 500 milliseconds, then get all of them, and then as you can see, we're hanging here, and that's because RX is waiting for TX to be dropped out of scope, which it never is until the end of the parent async block here. And that's never going to happen because RX is waiting for TX, and TX will never be dropped. We could fix that by dropping TX after we're done with the loop here, but I did something else. I went ahead and declared a TX fut and an RX future as well. And then we're going to join them. So these are going to run at the same time, so we're not going to have to wait for TX to finish until we send to RX. Instead, it's going to concurrently run the two, and as soon as something comes in from the transmit side of things, we're going to await, and then the runtime is, or should I say the join function here is going to see that, okay, well, we have the RX future to work on, and then it'll go ahead and receive, except this is going to still deadlock because just for the reason I described a minute ago. So the way we can solve that, instead of dropping TX, is we can move TX, async move. We can move the TX end of the channel into our future here, much like with closures, and that gives this TX future ownership of TX. So as soon as the TX future is done, TX will be dropped, and RX can gracefully end as well, and that'll be the end of our program. So we'll go ahead and cargo run. And as you can see, we're streaming the values from the transmit, and we receive them in real time from in the receiving future, and then we end the program without having to control C our way out of it. These channels in the TRPL crate also are multi-producer single consumer, so we can go ahead and create a second transmit end of the channel, and we can create two transmit futures here, and they're going to both transmit to the receiving end. We have TX1, RX, and then the TX with the original one, and again we're moving the transmit end of the channel into here so we don't deadlock. And instead of using the join function, we're using the join macro from the TRPL crate, and this allows us to await on an arbitrary number of futures. So we'll go ahead and run this, and as you can see, we're streaming from the transmit futures into the receiving, and we ended gracefully. That's it for this video. I wanted to keep it short and sweet, not go over too much detail, and I'll see you in the next one.